What if I told you that right now, at this very moment, something from another star system is screaming through our cosmic neighborhood at speeds that would cross the entire United States in 90 seconds? What if I told you this visitor has already passed Mars, and scientists can't explain half of what they're seeing? And what if the most disturbing part isn't what we know, but what happened during the 6 hours when every space agency on Earth suddenly went dark? This is the story of 3IATLAS, and nothing about it makes sense. When astronomers first spotted this interstellar wanderer in early 2024, they thought they had it figured out. Another icy comet, probably ejected from some distant star system billions of years ago, now passing through our solar system on its way back to the void. Standard procedure: observe it, catalogue it, publish a paper, move on. Except 3IATLAS had other plans. The first warning sign came from the brightness measurements. Comets follow predictable patterns. As they approach the sun, ice turns to gas, and they get brighter in ways we can calculate months in advance. It's basic physics, the kind of thing undergraduate astronomy students learn in their first semester. But 3IATLAS looked at those calculations and laughed. Instead of a smooth, predictable curve, the object's brightness jumped erratically. It would suddenly flare to 10 times its expected luminosity, hold that brightness for hours, then plunge back into darkness. Then it would do it again, but at different intervals, with different intensities. Researchers ran their models over and over, adjusting for every variable they could imagine. Solar wind variations, outgassing events, surface composition changes. Nothing fit. Dr. Rebecca Morrison at the Keck Observatory in Hawaii watched the data stream in with growing confusion. "I've studied comets for 20 years, she told her team during a late-night observation session. They don't behave like this. It's like watching a light switch being flipped on and off, but there's no one holding the switch." But brightness fluctuations were just the beginning. When spectroscopy teams analyzed the light reflecting off 3IATLAS, they found something that shouldn't exist. The dust particles surrounding the object were polarizing light in the wrong direction. Let me explain why this matters. When sunlight bounces off dust grains in space, it creates a measurable pattern called polarization. Every comet we've ever studied, every single one in the history of astronomy, shows positive polarization at certain angles. It's so consistent that we use it as a fundamental diagnostic tool. Finding negative polarization would be like discovering water that flows uphill. It just doesn't happen. Except 3IATLAS showed negative polarization at -2.77%. Not a slight anomaly, not a measurement error, but a clear, repeated, impossible reading that appeared in data from multiple independent observatories. The dust around this object was fundamentally different from anything in our solar system. Either this came from a region of space where matter forms under completely different conditions, noted Dr. James Chen at MIT, or we are looking at processed materials, engineered materials. He didn't say alien technology out loud, but everyone in the room heard it anyway. The trajectory deepened the mystery. Random objects from interstellar space can come from any direction, any angle. They should arrive like scattered rain, hitting our solar system from every possible orientation across the sphere of the sky. But 3IATLAS came and aligned almost perfectly with the plane of our solar system, the flat disk where all our planets orbit. The math is brutal. The chance of this happening randomly is about 1 in 50,000. Not impossible, but uncomfortable. Like flipping a coin and getting heads 15 times in a row. Technically possible, but you'd start questioning whether it's actually a fair coin. Then there's the timing. 3IATLAS made its closest approach to Mars on October 3, 2025, passing within 18 million miles. Close enough for detailed observation. Close enough for our rovers and orbiters to capture unprecedented imagery of an interstellar visitor. This was going to be the opportunity of a lifetime, a chance to study an object from another star system with instruments designed to examine planetary surfaces in exquisite detail. And that's exactly when the blackout happened. Multiple NASA websites went offline. Data feeds from Mars orbiters stopped transmitting. The Deep Space Network, our primary communication system with spacecraft throughout the solar system, experienced what officials called technical difficulties. For 6 hours, during the most important observation window in modern astronomy, we went blind. The official explanation cited the government shutdown, routine maintenance, and communication satellite issues. But the timing felt too convenient, too precise. Space agency veterans noted that the Deep Space Network has redundant systems specifically designed to prevent total communication loss. For everything to fail simultaneously, during those specific 6 hours, stretched credibility. What happened during those 6 hours? We may never know the full story, but amateur astronomers, operating independently with their own equipment, captured something extraordinary. Frame-by-frame analysis of their footage shows a brief, intense brightening of 3IATLAS during the blackout, followed by what several observers describe as a directional emission, a focused release of material that appeared controlled rather than explosive. When official communications resumed, the object's trajectory had shifted by 0.03 degrees. Sounds minor, right? Except such a change requires a force that has no natural explanation at this distance from the Sun. Comets can alter course through outgassing, but it creates visible changes that last for days or weeks. This was different. Precise. Almost surgical. The mass calculations raised even more questions. Based on how the object's gravity affected nearby dust and gas, researchers estimated 3IATLAS weighs approximately 73 trillion pounds. That's roughly 6 million times the mass of our largest rockets. For something that's sized to change direction without massive, visible outgassing suggests either an internal structure far denser than normal cometary material, or an ability to generate thrust in ways we don't understand. Dr. Avi Loeb at Harvard, known for his controversial theories about previous interstellar visitor Oumuamua, ran detailed calculations on 3IATLAS. His conclusion was characteristically bold. There's a 30 to 40% chance this object isn't entirely natural. Look at the evidence objectively. Loeb argued in a paper that drew both praise and criticism. Unusual trajectory aligned with our ecliptic plane. Anomalous polarization unlike any known comet. Precise timing that brings it near multiple planets. Unexplained course correction. At what point do we stop calling it coincidence and start considering alternatives? The composition analysis added fuel to the fire. Standard comets are essentially dirty snowballs, water ice mixed with dust and trace chemicals. But 3IATLAS showed a chemistry that didn't match expectations. High concentrations of carbon monoxide and cyanide, yes, but also spectral signatures suggesting an environment more similar to Mars than to the frozen regions where comets typically form. It's almost like this object spent time near a planetary surface, suggested Dr. Sarah Mitchell at Stanford. The chemical ratios point to formation conditions that shouldn't exist in deep space. Either it came from a very unusual stellar nursery, or it's carrying materials from a planet or moon we've never seen. The shape added another layer of strangeness. Most comets are roughly spherical or slightly elongated. 3IATLAS appeared stretched, almost cylindrical, with an aspect ratio suggesting deliberate design more than random accretion. High-resolution imagery, captured before and after the blackout, showed surface features that some researchers described as structured, with variations in albedo that formed patterns rather than random splotches. Natural weathering creates chaos, noted Dr. Lisa Park, a planetary geologist. What we are seeing here looks organized. Regions of different reflectivity arranged in ways that suggest purpose. I'm not saying it's artificial, but I'm saying it's weird. The thermal emissions told their own story. Infrared observations showed that 3IATLAS maintained remarkably stable temperatures despite varying distance from the Sun. Most comets experience wild temperature swings. This object stayed within a narrow range, as if something were regulating internal heat distribution. Even more intriguing were the hotspots. Small regions of the surface periodically became warmer than their surroundings, appearing and disappearing over hours. The pattern of these hot spots wasn't random. They formed geometric arrangements, lines, and angles that shifted across the object's face like markers on a map. When 3IATLAS survived a direct hit from a coronal mass ejection, a massive solar storm that should have dramatically altered or even destroyed a typical comet, it barely changed. Scientists expected fragmentation, violent outgassing, maybe even complete disintegration. Instead, the object's outer cloud swelled slightly, then stabilized. It shrugged off forces that would demolish a natural comet. That level of structural integrity is remarkable, Dr. Kevin Torres noted. Either this object is made of materials far stronger than typical cometary ices, or it has some form of internal reinforcement. Both options are fascinating and troubling. The rotation added to the enigma. Most asteroids and comets tumble chaotically, spinning on multiple axes from billions of years of collisions. 3IATLAS rotates smoothly on a single axis with a stable period, suggesting either perfect symmetry or active stabilization. Natural objects rarely maintain such clean rotation. Then there's the context that makes some researchers deeply uncomfortable. 3IATLAS came from a specific direction in space, a region where any observers could have seen Earth transiting across our sun using the same techniques we use to find exoplanets. If an advanced civilization in that direction had been watching, they would know exactly where we are, what kind of star we orbit, and potentially even details about our atmosphere. The flight time from nearby stars in that region to our solar system, traveling at 3IATLAS's speed, would be thousands of years. Long enough that whoever sent it, if anyone did, might not even exist anymore. Or they might be waiting, patient beyond human comprehension, for their probe to report back. Dr. Suzanne Fiedler has proposed an alternative explanation that's equally mind-bending. What if objects like 3IATLAS are planetary seeds, massive interstellar bodies that kickstart planet formation when they enter young solar systems? Her models suggest that planets could form much faster if they had large pre-made cores to build around, rather than slowly accumulating from dust. If true, then Jupiter might contain material from an ancient interstellar visitor that arrived billions of years ago. We might all be made, in part, from stuff that came from other stars, delivered by objects like 3IATLAS. It's a beautiful idea, though it doesn't explain all the anomalies. The upcoming Jupiter encounter on March 16, 2026, will be critical. 3IATLAS will pass within 33.5 million miles of the gas giant, close enough for detailed study. Jupiter's intense magnetic field and radiation environment will provide the ultimate stress test. If this is natural material, we'll learn about exotic comet chemistry. If it's something else, if it can navigate that environment with purpose and control, we might finally have conclusive evidence. Every major telescope is being prepared. The James Webb Space Telescope will examine it in infrared wavelengths that can penetrate dust and gas. The European Space Agency has coordinated observation campaigns across multiple spacecraft. Amateur astronomers worldwide are organizing watch networks to ensure continuous coverage that can't be blacked out or censored. Because here's what everyone is thinking but few are saying publicly: we might be living through first contact, and we don't even fully realize it yet. Not the Hollywood version with ships landing on the White House lawn. Not the science fiction fantasy of aliens who conveniently speak English and want to share technology. But something stranger, more subtle, more profound. Contact as observation. Contact as a probe sent thousands of years ago, arriving now, studying us with instruments we barely understand, collecting data that will travel back across the light years to minds we can't imagine. Or maybe it's nothing. Maybe 3IATLAS is just a rock, an unusual one certainly, but ultimately natural. Maybe all the anomalies will have explanations that fit within known physics. Maybe we are seeing patterns where only chaos exists, finding meaning in coincidence because we desperately want not to be alone. But the data keeps coming in, and it keeps refusing to fit. Each new observation adds another piece to a puzzle that doesn't look like any picture we've seen before. The polarization that shouldn't exist. The trajectory that's too perfect. The timing that's too convenient. The course correction that defies explanation. Dr. Margaret Chen at Cambridge perhaps framed it best: we are at a crossroads. Either we are witnessing phenomena that will revolutionize our understanding of comet chemistry, interstellar material science, and planetary formation, which would be extraordinary. Or we are seeing evidence that intelligence exists beyond Earth and has achieved interstellar travel, which would be world-changing. Both possibilities should humble us. The question isn't whether 3IATLAS is important. It obviously is. The question is what kind of important it turns out to be. A scientific curiosity that expands our knowledge? Or a messenger that transforms our place in the cosmos? In a few months, we'll have better answers. The Jupiter encounter will reveal details we can only guess at now. Either the object will behave as a comet should, confirming natural origins, or it will do something that forces us to confront possibilities we've only imagined in our most speculative moments. Until then, 3IATLAS continues its journey through our solar system, silent and inscrutable, carrying mysteries that might reshape everything we think we know. It's out there right now, beyond Mars but not yet to Jupiter, moving at speeds that would make it invisible to the naked eye but inescapable to our instruments. Watching, measuring, perhaps reporting, or perhaps just existing, a cosmic accident with properties so unusual that we mistake complexity for intent, seeing intelligence where only nature's infinite creativity resides. Either way, we can't look away. Because whether 3IATLAS proves to be an alien visitor or the strangest comet ever observed, it's already changed something fundamental. It's reminded us that the universe still holds secrets. That space isn't empty, but filled with wonders we are only beginning to understand. And that sometimes, the biggest questions aren't the ones we ask, but the ones that come looking for us, moving at 124,000 miles per hour through the darkness between worlds.